Okay, I think we can start.
Okay.
Okay. Hello, everyone. Welcome to our webinar. Today, we will be speaking about filming mines compared to traditional water treatment methods. Thank you for joining us. I know that for some of you is a bit late in the afternoon, and for others is really, really in the morning, but we truly appreciate your presence. My name is Irina Stoican, and I'm marketing manager for Fineamin. And I will be co-hosting today's session with my colleague, Mustafa, who is our sales manager. Mustafa?
Yeah. Hello, everyone. It is our pleasure to start this webinar series. This will be the first, and we'll have the further ones, and they will be scheduled and they will be announced. So it is our pleasure to introduce ourselves as well as the capabilities of our companies. As Irina said, my name is Mustafa Emran Koken, and I'm basically regional sales manager for Fineamin SA, as well as the country manager and director for Fineamin Turkey. So let's start, I would say. And first of all, Irina will present a part of our, let's say, company profile. Then I will follow the technical session. Let me open the presentation. Hold on a second. Share.
For those of you who are not familiar with Fineamin, we are a Swiss-based manufacturer. We manufacture industrial water treatment chemicals, and we specialize in film forming amines. We combine performance, safety, and care for the environment. We try to innovate as much as we can, and we try to help industries optimize their water treatment strategies. We have a lot of sustainable, customized solutions for our clients. We are currently active in almost 50 countries. And while our main office and production plant is in Geneva, Switzerland, we also have multiple other offices across the world. For example, in Germany, in Singapore, in Turkey, and our most recent office is in Mexico. Um, Along with that, we have almost 200, more than 200 engineers supporting Fineamin. So, today we will be speaking about how filming mines are changing the game when it comes to protecting industrial systems, industrial boilers, cooling towers, and closed loop systems. So, Mustafa will cover subjects like common water treatment issues, comparing the usual water treatment, common chemicals with the film forming amines. And at the end, we'll have some time left for the questions. So I think we can start. Mustafa?
All right. So thank you, Irina. Basically, as I said, we will be covering, this is not I mean, it will be just the first webinar for film forming amines by Fineamin Technologies. Definitely, we will have other topics and other subjects to cover. So in this one, we will be just introducing the film forming amine molecule, as well as how this molecule or molecule-based treatment is different than the traditional one. And let's start by some terminology in order to speak and understand the same language. Uh, Many people, they may pronounce it, the word amine set differently. I would say that probably the first very well-known ones are amines or amines. So it is the same. So we can say polyamine or polyamine. And you can also hear film forming amine or film forming amine, as well as we can abbreviate as FFA. So basically, we all mean the same thing by this terminology. Okay, so film forming amine entered into our lives for water treatment in 1970s, and the idea is to form a monomolecular film over the metal surface through some adsorption process, and we'll show a bit about the mechanism in the later slides. And this film will be generating a barrier between water and the metal because of the nature of the film itself being hydrophobic. So you can see the general, let's say, formula of film-forming amines with different alkyl chains, as you can see. And when this number, the n is equal to 0, we are talking the first primitive film-forming amine or film-forming substance, that is octadecylamine. So definitely then there will be further development and progress, and then we are coming into the olediamines, that is the main film-forming amines we are using in our products, for instance. So we are talking about bulky and aliphatic film-forming amines that will be absorbed into the metal surface. As I said, film-forming amines, they are like surfactant molecules, like a micelle, in other words. So we are talking about the head and the tail. So how the interaction will be taking place is basically through 3 different interactions. The first one is we are having a hydrophilic head that will be absorbed to the metal surface. This is the absorption process. Then between the heads that are hydrophilic, we will have the ionic interaction. And then the tails being a hydrophobic, we will have van der Waals forces between the tails. So all these interactions will generate a barrier, and they will expel anything that is called hydrophilic. So this is why we have the mechanism without any oxygen scavenger, the ability for film-forming amine treated surface to expel dissolved oxygen, because dissolved oxygen is hydrophilic. Similarly, if there is anything dispersible and that has with the hydrophilic nature some hardness levels that are insoluble in the water, let's say, this will be also similarly expelled by this film. And the beauty of this, at the end, that film absorbed on the metal surface has nothing to do with the changing of thermal capabilities. So it will not be costing any energy by making that film. So interesting molecule and interesting applications. And as you can see, we have a diversity of treatment concerns, as well as the markets that we are being addressing for the treatment. So the most well-known part of the film-forming amine-based treatment is basically steam boilers. So we have references up to 210 bar, and then it can be used in, as you see, water tube boilers, in recovery boilers, in fire tube. It can has also applications in the closed loop, whether it is a cooling system or it's like district heating or heating loops. Similarly, and probably the most challenging, is also using of film-forming amine-based technology in open cooling loops in cooling towers. Coming to industry, we will have, and we have applications in heavy industries like power plants, refineries, petrochemical plants, pulp and paper, steel industry. We have the applications in the middle market, automotive, metal, further metal processing, constructions, textile, chemical processing. We have the applications specifically for food and beverage, because we have also products with NSF certification that will come into that in a later slide, as well as in the next coming webinar. Then for commercial institutional market, we also have applications in the hotels, hospitals, airports. So wherever there's a water loop, definitely this chemical philosophy can have the application. So let's come to first important applications of the film-forming amine-based technologies in boilers. So the traditional treatment has the concerns of controlling corrosion, scale, and carryover, means something also for steam quality. So the first concept is using an oxygen scavenger, so that we avoid the formation of the oxygen-related corrosion. For the internal treatment, then the most common used chemical is the phosphate, along with dispersants And for the steam and condensate treatment, it can be ammonia and more advanced way, neutralizing amines mixtures, amines with different distribution ratios and basicities. So when we move into the film-forming amines, basically, we are not using oxygen scavengers, we are not using phosphates. We are having all organic formulations composed of polyamines. Again, this is film-forming amines, volatile, also known as neutralizing amines mixtures, as well as polymers. So this is fully, once again, let me underline, all organic approach. So
Mustafa, sorry to interrupt you. Can you speak a bit louder?
sure. So what are the basically advantages for the film-forming amine-based philosophy over the traditional approach? So in the traditional approach, we are talking about primarily for the oxygen corrosion inhibition, external methods, and the chemical treatment. External methods are like the aerator to remove mechanically the dissolved oxygen and dissolved gases, and economizer in case the temperature of the boiler feed water is low because the steam is used in the process or the condensate return is dirty, so it's being discharged, so on and so forth, and to increase the boiler feed water temperature, as well as anything that will be left from the mechanical, let's say, deaeration, internal methods to increase, to remove the dissolved oxygen from this system. But we have the concern. So let's start by the first, let's say, fact that we should always understand, that the solubility of dissolved gases is inversely proportional with the temperature. So lower the temperature, higher the dissolved gas concentration. This is also true for the oxygen. So when we are using an oxygen scavenger, and there might be some systems without any deaerator and without any economizer, so we are solely dependent on the performance of oxygen scavenger. And oxygen scavenger is a chemical that reacts stoichiometrically with the dissolved oxygen. So as much as we are aware of the system temperature, we can dose correct amount of oxygen scavenger, and then we will be able to measure the residual of that oxygen scavenger. For example, for low pressure cases, the most preferred oxygen scavenger is sulfide. Then, if we are unable to, let's say, know the exact boiler feed water temperature, hence we are unable to dose enough oxygen scavenger, then we will not be able to read residual of the oxygen scavenger. That also means that there will be free dissolved oxygen in the system, and being a gas, it will also go to the steam, and it can generate problems in the condensate and steam lines. So at the end of the day, if one person has been having an issue about the high level of oxygen scavenger consumption, like in case of the sulfide, then we have another issue about the cost. Why? Not only about the chemical cost, but we need to increase the level of the blowdown because it is something inorganic. Sulfide is something organic, and it will contribute into TDS. So the second part of the traditional treatment is about the internal treatment in the boilers. And as we said, the most known chemical for the internal treatment is the phosphate. So when we are having a phosphate, yes, in case there is a hardness leakage to the system, and we have been generating calcium phosphate, it is a, let's say, a soft sludge, it can be removed easily. But at the end of the day, over and over accumulating phosphates, it will be generating overheatings, steam blanketing, and even tube ruptures. And additionally, even if we think that we will dose enough phosphate, but then because of the control parameters, we need to increase the blowdown, then we'll be increasing blowdown rates, which means that we're increasing the energy cost. And primarily for medium and high pressure systems, we have another issue about the phosphate. we are dosing the phosphate, and we are not being able to measure the phosphate we are dosing, a phenomena that is known as phosphate hideout. So why this phenomena occurs? Simply because of the change in the load, startup conditions, and based on the process demand, changing the steam production, increasing and changing, and let's say making a variation in the load. And similarly, changing the fuel type, changing the burner configuration, and many other factors, they can favor the formation of the phosphate hideout. And when it happens, it is difficult to control. Then the third point is about the steam quality. So what is this quality for the steam that can tell us? In case we have a problem called carryover, then the steam quality will be affected. That means the boiler water will be sucked into the steam lines in forms of fine droplets. So we have two reasons. One is, let's say, mechanical carryover, known as priming. And the second one is chemical carryover, that is known as foaming. In low pressure cases, again, this is a very well-known, let's say, issue, well-known problem, because due to the high consumption of inorganic chemicals, we can easily go beyond the limit of conductivity and TDS, and this will facilitate the formation of the foaming. So why we are being simply talking about that specific part of the problems about the oxygen scavenger and the internal treatment and the carryover and the steam quality is because we will have those problems that will be totally not present in film-forming amine-based treatment. And speaking which high pressure systems, then we have another important issue. That is the type of the oxygen scavenger people are using. As you know, the most efficient oxygen scavenger for high pressure cases is known to be hydrazine, but hydrazine is carcinogenic. So then there are regulations and safety and handling issues. People, they are moving away from that oxygen scavenger. Similarly, another molecule that is used instead of hydrazine is carbohydrazide. But carbohydrazide, at the end, when it is being applied at temperatures between 135 and 200 degrees centigrade, it is converted by the path into the hydrazine. So these are the health concerns about hydrazine and carbohydrazide. Beyond that, technically, as you see of the decomposition patterns, both hydrazine and carbohydrazide will decompose to ammonia. So if the systems have any copper or copper alloys, then ammonia is highly corrosive to the copper and copper alloys metallurgies. So what we can then ensure about film-forming amine treatment by Fineamin, our treatment has no sulfide. And our treatment has no phosphate. So no inorganics, no contribution into the TDS remarkably. So we should not worry, even if, let's say we are talking about a system with 40 degrees centigrade of boiler feed water temperature, or 70 degree or 99, we will not be changing the dosage of our product because everything is dependent on the formation of the film, and that film will repel the dissolved oxygen. So there's no phosphate, means there's no possibility to have anything related of phosphate as phosphate scaling or phosphate hideout. Similarly, no inorganic components, so no possibility for chemical carryover because all organic, and being an all organic substance, then the contribution TDS is really, really low. There is no possibility to reach TDS or conductivity level that is being overpassing the limit of, let's say, 3,500 ppm as TDS or 7,000 microsiemens per centimeter in the case of low pressure boilers. And Of course, there is no any carcinogenic components. So there is no hydrazine, there's no hydrazine derivatives or anything being that level of toxicity. So it really fulfills health and safety regulation. So in overall, for a treatment in boilers, we are talking three main costs. So the first and the biggest cost is about the energy. The second cost is about the total makeup water preparation. And the third one is about the chemical treatment cost. So when we are been regulating something through film-forming amine-based treatment supplied by Fineamin, that will be not increasing TDS, hence regulating the blowdown level, we will be saving energy. We will be saving total water preparation, and we will also generating a remarkable saving for chemical treatment cost. So not only about the technical aspect, but also economical aspect, we will have remarkable savings. So that molecule that is being used in boilers have also a further applications in boiler systems. One of the things is that many people they may ignore is the situation of standby boilers. Now, as you know, if you are thinking to stop a set of boilers for some time and they are not being kept under the pressure, means it will be preserved in cold way, then if we are talking about more than 2 days time, then we will see the color change of boiler water because of the corrosion. So then the people might think to make a wet preservation. And wet preservation, depending on the length and period of the preservation, it may require to use extensive amount of oxygen scavenger. And again, such a method normally asks for, first of all, about sulfide, if it is up to 30 days of standby period. If it is more than 30 days, then even we can't use sulfide because sulfide will be converted into sulfate and will generate some, let's say, corrosion tendencies as well as the stress on the metal surface. So if it is more than 1 month, then the oxygen scavenger type should change. And then when the people, they are thinking to take the boilers back into the operation, then there should be huge level of blowdown to remove any, let's say, inorganic or high TDS residuals, and then start the operation. Of course, over 3 months and in some interpretation over 6 months, wet preservation is not preferred, then it should go through the dry preservation method under the inert gas blanket. Now, what we see as a superior advantage of film-forming amine treatment. Basically, if we are talking about up to 6 days, even we are stopping the dosing of the chemical, the film will remain intact. So there is no worries in that regard. No any particular measures to take into consideration. When we have cold boilers, depending on, let's say, the level of the water in the drum, so on and so forth, we are just considering to adjust the pH as well as consider a polyamine excess to be considered, and we have detailed procedures for that. But the loading of, or let's say the overload of polyamine molecule, film-forming amine molecule in the system is much minimal compared to sulfide or any relevant, I would say, organic scavenger. Hence, when we are thinking to start the operation, also the blowdown level will be much more minimal compared to traditional method. But the key point here is, if we have a boiler, set of boilers, and if we are changing it, within 6 days from boiler A to boiler B, or we are having only 5 days operation during the working days, and then during the weekend we stop it, we don't need to consider, and we don't need to worry about the formation of corrosion in that sense. So another interesting application of film-forming amine molecule is during the boiling out. During the boiling out is an important step, because if you don't have a clean boiler surface and well-cleaned boilers, then you will have all the time problems, and you will be working, maybe you will be rethinking to make another cleaning or increase the blowdown for over some time in order to remove all these dirt and oil residuals, so on and so forth. And then the people in the traditional methods, they may even just think to use water. They may be using, unfortunately, some acid that even we don't want to mention the name because it is very, very dangerous and hazardous. Then commonly people might think to use trisodium phosphate, caustic soda, and or the mixtures of both, trisodium phosphate with caustic soda, so on and so forth. And here, definitely we are being bound into certain facts: type of chemical for the boiling out, handling and safety, discharge, environmental limits, regulations, and performance. So the length, how much time we should do it, how we will get the performance, how we will handle the waste, how we will handle the material itself, if the material is hazardous based on safety, health, and environmental perspective. So in that regard, it is really, really problematic thing. But with film-forming amine treatment by Fineamin, interestingly, even with the same, ideally, treatment chemical at a different application and dosages, of course, then we can use the same product to make the boiling out process. It is much easier to handle and much easier to store due to the biodegradability and environmental friendly perspective. Better cleaning, because as we said, this is like a surfactant, like a micelle, means you have a head and a tail. So you have this surfactant capability. And then at the end, you will be generating also better homogeneous single layer magnetite layer. Reduction of downtime, which means also the cost reduction. So overall, we are having several advantages. So from the start, before we take the boiler into operation by film-forming amine-based treatment, and continuation by the treatment of Fineamin product, and then in case of an idle standby, using the same chemical for that, is a nice sequence and complete sequence, in fact, for the treatment. Then the well-known boiler treatment concept by film-forming amine molecule, they had the applications also in closed cooling and heating circuits. Now, after the chromate being carcinogenic, let's say the market switched to molybdate and nitrite, and definitely molybdate is a heavy metal, and in some countries there is a discharge regulation, and as a molecule itself, it has no dispersing capability. It is inorganic, mostly used as the sodium molybdate, let's say, salt, and non-biodegradable and not environmental friendly. Definitely, it has its advantage as lower contribution to electrical conductivity. In certain loops, people may ask for lower contribution to conductivity. So in that circumstances, molybdate-based treatment is much ideal. And in case there is a kind of an oxygen in the systems, means like semi-open or sometimes called semi-closed systems, then molybdate can be used, but it is quite expensive. So when becoming nitrite, nitrite is more like industry standard, but environmentally, it is toxic material. Even the shipment of the active itself is a bit difficult, +6. At the same time, nitrite is a food for bacteria. So you can generate especially nitrifying bacteria. Then, along with nitrite-based treatment, biocide application is a must. Again, it is inorganic, mainly in forms of sodium salt, sodium nitrites. So it is a non-dispersing, at the same time non-biodegradable and non-environmental friendly. And if there's an air intake ingress in the system known as semi-open or semi-closed systems, we cannot use nitrite because nitrite will be converted into nitrate. Beyond being a good corrosion inhibitor for the aluminum containing systems, for ferrous metals or for cuprous metals, it is not a strong corrosion inhibitor as nitrite. So then nitrite for semi-open or semi-closed systems fail. And then relatively, we are using high dosages. Again, industry standard between 600 ppm to 1000 ppm as nitrite. It may go down a bit because taking into consideration chlorides and sulfate levels, but normally we don't want to underdose nitrite. So at the end, we are generating high contribution to electrical conductivity. So these are the two comparative points of nitrite and molybdate in the close cooling and heating treatment. So what we can offer as Fineamin treatment by Fineamin, number one, although our chemical is having a nitrogen, but it is in a polymeric way, so it is not a nutrient for bacteria. So it does not promote microbiological fouling. Of course, in closed cooling systems, we still use a biocide, but the frequency of shock application and dosages are much more moderate. So it is not toxic. We have more than, let's say, 90% biodegradability, so it is more environmental friendly. And again, no heavy metal, nothing in that regard. So as molybdate case, it's very ideal for the system asking for lower conductivity contribution. As a molecule being like a surfactant and micelle, it has strong dispersive power. And for the people who might say that, okay, these are very nice points, but what about the cost of application? It is extremely competitive and extremely economical too. So this is really seen one of the, let's say, very nice alternative to molybdate and nitrite in closed cooling and heating. The most challenging part of the film-forming amine-based treatment is in open cooling loops. Now, traditionally, for low pH, low hardness waters, like soften or RO-based makeup waters, we are preferring to use zinc phosphate and zinc phosphate related treatment approach. So, because zinc does not need hardness to make the protective, the cathodic film for the protection. However, we should also consider certain other facts. The first one, when we are using zinc-based treatment, we should consider strict pH control. Because if we go anywhere more than 8.5, then we may see the formation of zinc bulk precipitation. So if we increase the level of the phosphates or we are using just the phosphates or phosphate with little level of the zinc, but at the end of the day, we are using something that can easily precipitate out. So we need to consider relatively higher levels of dispersant to prevent zinc phosphate scaling. And then both zinc and phosphates, they have the concerns for environmental regulations due to the toxicity, biodegradability, so ecological aspects. What we propose? We propose, especially where we have that zinc-based approach, film-forming amine-based technology, and basically we don't need to worry about the pH control if we ensure that Langelier saturation index or Reisner index, whatever we follow, the limits are met. And then there will be no metal or inorganic phosphate discharge. We have lots of applications, especially in Turkey, for that type of approach, replacing successfully zinc-based treatment more than decades. Now, for the second type of makeup, water qualities means scaling tendency waters with some hardness. Again, one of the most common philosophy is all organic, means phosphonates and polymeric dispersant mixtures. So in certain scaling waters, if we have high level of chlorides and sulfates that are the source of peeling corrosion, then phosphonates may not be providing enough and sufficient control of the corrosion. And if somebody is also using some, let's say, oxidizing chemistry, the phosphonates can be degraded as well. So for the scaling tendency waters, because there will be lots of hardness and possibly calcium carbonate formation, etc. So we are not going only by film forming amine molecule, but we are going mostly a hybrid technology. Means we are having a mixture of film forming amine with environmental friendly phosphonates. So in that regard, we are generating better corrosion results and also lowering phosphate discharge. So this is also an approach that we are using in some countries with very acceptable results, and compared to let's say traditional treatment, the people, they are much more technically satisfied, as well as the cost. Okay, so this molecule, film forming amine, is a special molecule. So definitely one may think that, okay, we are using it, but what we should do in order to control analytically that molecule, then there are different methods. Again, measuring some organic molecules are not very easy, but it depends on also the practice, I would say. And there are very well-known methods, and two of them, one is tetrametric, is known as Hale method, and the other is spectrophotometric, Rose-Bengal. Basically, we are measuring the excess. So as we do in other treatments, so we have the film formed, and there will be some excess molecules in the system. And through this analytical control, we are measuring that excess, so that we are sure that the protective layer is there, continuous, and maintained. For the Rose Bengal, we also produce our own reagents, and we have our own calibration curves to be shared in case that people, they would like to introduce this method into the spectrophotometer program of HUC, Dr. Lange. So this is also possible to share our curves and the method how to introduce to the system, to the spectrophotometer, in order to have a standard method for such measurement. So let's wrap up in terms of the advantages. So we are talking about, in most of the case, single drum, all organic products with the molecule of surfactant capabilities, means online cleaning efficiency, single dose, single pack, so you dose only at one point in most cases, and there are some other points that I will be mentioning in the coming slides. No possibility compared to, let's say, traditional methods in terms of the molecule type, like toxicity, biodegradability, discharge limitations, and also the workers' safety. So it is a compact, easy, and superior advanced technology compared to traditional treatment. How we supply this film-forming amine molecule? So we are supplying as a mixture. So basically, our treatment chemicals or drums contain multiple actives. So we have, again, the most critical and let's say the core of the philosophy is film-forming amines, polyamines. Then we have mixtures of neutralizing amines for the pH adjustment. Then, if you are talking about low pressure case, for us, low pressure, I would call, let's say, criteria is being lower than 120 bar. So for any system lower than 120 bar, we are also using polymeric dispersant. And if it is more than 120 bar, we don't. There are also cases where it is lower than 120 bar, and also we don't use it. It depends on the industry, but generally, if it is less than 120 bar, we use polymeric dispersant. And although, as an idea, as the philosophy of the treatment, we don't need oxygen scavenger because everything is, as we said at the beginning, formation of the film, and that film, that hydrophobic film, will expel anything hydrophilic like dissolved gases. But in certain industries and in certain clients, measurement of dissolved oxygen is a key performance indicator. Apparently, that film-forming amine will prevent dissolved oxygen, or let's say oxygen corrosion, oxygen-related corrosion, but it will not be reacting with dissolved oxygen and remove it. This is why if we have only mechanical removal like the aerator, the performance of or the final oxygen scavenger level is dependent on the performance of the aerator. So if the people, they have a much strict levels of dissolved oxygen measurement, then we have also technologies and embedded organic oxygen scavenger molecule in our product. But again, this is just case by case. Then we are supplying that treatment philosophy in different applications, like in boiler treatment, we have most of the time single drum all organic, one dose at single point. Then there might be cases that the people, like I would say in certain power industries, that they have concerns about cationic conductivities, about certain limits, so on and so forth, and they would like to have film-forming amine as a complementary, let's say, product or active to the all-volatile treatment. This is also possible. And then in some regulations, in some countries, the people might say that, hey guys, we don't want to use any cyclohexylamine. Then we have also multi-drum solution, cyclo-free. That is also possible. And for food industry, we have also special products with NSF, G6, and G7 conformity. For the closed cooling and heating circuit treatment, we have most of the time, again, single drum corrosion and scale control for ferrous and yellow metal containing systems like copper and copper alloys, brass. And obviously, if we have aluminum, we can't use a generic product that easily because aluminum being an amphoteric and also at pHs more than 8.5, it may go under corrosion. So we have also now a special product for the systems containing aluminum. And as I mentioned, for open cooling circuit treatment, we have single drum corrosion scale inhibitors that should be complemented by biocides and any other chemical that has been required for, let's say, corrosion tendency, highly corrosive tendency waters, makeup waters. And we also have hybrid technologies, phase corrosion and scale inhibitors, film-forming amine, along with environmental friendly phosphonates. So not only this, but we also worked and we have also available special products that contains a tracer. So basically that fluorescein molecule can be measured after the dosing, ensuring automation of the product to the system. Now, it is not extremely common to have such automation in boiler systems, but in case it was requested, it was demanded, definitely we can also supply such type of products and those products are known as Fineamin 80 series. So I would like to thank you for your participation for this webinar, and we are looking forward to seeing you in the next ones. And you can definitely contact us through our email addresses, mustafa@fineamin.ch, geneva@fineamin.ch. At the same time, I'm based in Istanbul, Turkey. So my WhatsApp number is Turkish, but it's always active. Feel free to add me. And then if you have any questions, any concerns, any further clarification, please do not hesitate to contact us. Now I'm stop sharing the presentation and we'll be going to question and answer session.
Thank you, Mustafa. If you have any questions, please write them in the Q&A section.
Okay. I have a question about measurement methods. Is there any particular brand that works better? I would not say that this is a tricky question, but it is always based on the best practice. In, let's say, low pressure cases, maybe the people, they can be much more satisfied because it is easier with calorimetric method. But if the people, they are looking more about the high precision and accuracy, definitely spectrophotometric method is the choice. Okay, so any other question? Again, just let me try to say it. I mean, next presentation will be focusing on the boilers. Now, we just gave here very coarse understanding, very coarse ideas, just to show in which treatments, let's say, film-forming amine can be a nice substitute in water treatment. So when we go one by one through the, let's say, boilers and close cooling and some case studies, definitely you will have better ideas and you will have much concrete cases in terms of the application.
Mustafa, there is another question in the chat.
Okay, so how can we calculate the dose? Good question. So basically, we have a guideline. I would say that we are going a bit in the reverse direction. What I mean by this, our aim, depending on other criteria, but generally for boiler cases, we are maintaining between 0.2 and 1.5 ppm of free film forming amine residual in the pure condensate return, not in condensate tank, in pure condensate return. Then how we can judge whether it is 0.2 or it is 1.2? It just depends on other parameters. So we don't get happy when we have just, film forming amine residual level. We look to pH. We also look the metal, dissolved metal concentrations, iron, copper, etc. So all together, when we evaluate, then we get satisfied. In terms of close cooling, for example, we keep it up to 2 ppm of film forming amine residual, provided again the pH and the metal, dissolved metal concentrations, iron, copper, whatever is present. Another question, for monitoring systems with tracers, where is exactly the location, the sample point? Very good question too, because in boiler systems, apparently the systems are extremely hot. Either if you would like to introduce the measurement, let's say the sampling point after the condensate and the boiler water whatsoever, so there should be always a cooling that is very, difficult, I would say, to heat exchange whatsoever. So mostly the ideal part is after the dosing of the chemical. Can we share the presentation? That's another question, Irina.
Yes, we will share the presentation.
Share it. Yes.
No problem.
Okay. And any other question? For systems that generate heat, is there a lower temperature limit for using this product? Good question. No. I mean, again, one of the superiority of this technology itself, for example, for boiler cases even, I would say that you can easily switch from like hot water boilers into steam boilers without any problem in terms of the application itself as a molecule. I mean, the philosophy of treatment. But for traditional treatment, that is not the case. So most of the time, you can use molybdate and nitride in closed cooling and closed heating, but you can't use definitely nitride and molybdate in steam boilers. But in this type of treatment philosophy, it is very diverse and it's very versatile. So we can't say that there's really a lower temperature limit. Whatever it is being, we consider ambient, let's say, temperatures to 210 bar related temperatures, more than 500 degrees centigrade, so on and so forth. It has its own application, no problem at all. Any other questions? So I think we are done. We are hoping to see you. We are looking forward to seeing all of you in our next webinar that Irina will announce shortly. And we will be covering as a next topic the application of film forming amine based technology specifically in boilers application. Okay, so
we'll also have some webinars where we will present exact case studies.
exactly.
One will be our colleague Wala.
Sure.
She has a very long experience with our products, and we will take a break for the summer. And from September, we will start again. We will present a case study we made together with a university in Germany. And we will continue with different subjects like boiling out, conservation of boilers, and more.
Exactly.
Just follow our LinkedIn page.
Yes.
Okay.
So
Thank you so much to everyone.
thank you and have a very lovely day and evening based on your time zone.
Bye.